x squared minus 14. Good thing we got a big drawing board here. Back to the drawing board. Yes, ma'am.
X plus 7 squared?
That's the same as x plus 7 times x plus 7.
Well, because it'll be x squared plus, and then 7 squared would be 49.
That's a good guess. Here's what you're saying. You're saying x plus 7 squared. Isn't that equal to, I'll put a question mark to say that, isn't that equal to x squared plus 49?
No.
What does x squared in parentheses, x plus 7 in parentheses squared mean?
X plus 7,
That's
x
right.
times x
It
plus 7.
means x plus 7 times x plus 7. And when I do that, I do not get another one. So we still got some extra space here. X plus 7 what? X plus 7x minus 7 is how...
You get a negative number.
X plus 7, x minus 7 is x squared minus 7x plus 7x minus 49. I get x squared minus 4. There's a difference of 2 squares. That's how the difference of 2 squares factors.
Well, what about x minus 7, x plus 7?
I think we just did that one, except with the twist. You square rooted. What can I multiply to get x squared? I'm sorry?
No solution.
What do we call something that I ask you to factor and it won't? What do we say?
No.
What do you say? Hey, if I asked you to factor the number 7, what would you tell me about the number 7?
It's a prime number.
It's prime. That's the word. If I ask you to factor something that will not factor, your response to that is, sorry, x squared plus 49 is prime. That's as far as it's going to go, ladies and gentlemen. Notice how wonderfully the difference of 2 squares factors. Notice the dead end that the sum of 2 squares gives you. Sum of 2 squares, dead end is prime. Difference of 2 squares, factors wonderfully easy. Yes, ma'am?
Does that mean that, like,
X
x could be equal to 7?
could be equal to 7.
Like, why what is the prime?
Okay, now we don't have an equation here. If we had that's equal to 0, we would have to ask, what can x be to make that true? All I'm asking you to do is start with x squared plus 49 and factor it. Now, what your question is going to be in, I think, chapter 3. When we actually answer the question, x squared plus 49 equals 0 does have a solution, but not in the real world. All right? Not in the world of real numbers. So we'll get to that a little bit later. Hey, you took out lots of pages on that one, huh? But we discovered that sum of 2 squares is, on the whole, prime. There are going to be some exceptions, but sum of 2 squares is prime. Don't spend a lot of time trying to factor that guy. All right, try this one. And here's the big old honking question. Is that the difference of 2 squares? No. Keep getting these multiple answers. A very simple question. You think you would agree with... Is that the difference of 2 squares?
No.
I mean, duh. I mean, is 64 a perfect square?
Yes.
That's a perfect... But is x to the 10th a perfect square?
No.
I mean, for x to the 10th to be a perfect square, there would have to be something I could multiply by itself and end up with x to the 10th. Is there? there would have to be something I can multiply by itself and end up with x to the 10th.
X to the 5th.
X to the 5th. Wait a minute. X to the 5th times x to the 5th. What do I do with those exponents? You sure do. Is x to the 10th a perfect square?
Yes.
It sure is. Didn't appear to be that way because 10's not a perfect square, right? But x to the 10th is, because x to the 5 times x to the 5 gives me x to the 10. What do you know? That is a perfect square. That means this is the difference of two squares. Which means I have to answer the question, what's the square root of x to the 10th? X to the 5th. By that, ladies and gentlemen, we're not saying what's the square root of 10. That's not what we're saying. We're saying what's the square root of x to the 10th, meaning what can I multiply by itself and end up with x to the 10th? X to the 5th, you're right. X to the 5th is the square root of this guy right here. Square, that's easy. Plus or minus. What in the world do you know? Now that's kind of surprising, right? It's supposed to be. I hope it was. I hope you got a little jolt out of that. X to the 10th is a perfect square. Try this one. Is that the difference of two squares?
Yes.
I heard more yeses than no's this time. If it's the difference of two squares, then you can tell me what the square root of this is. What is it?
X to the 12.
It sure is. X to the 12 times x to the 12 gives me x to the 24. What in the world do you know? And plus or minus 5. So let's make a general observation here, ladies and gentlemen. What's going to have to be true of the exponents before they are perfect squares? Even. Divisible by 2. If they are even exponents, you got yourself a perfect square. So, what's the square root? What's the square root of a to the 4th, b to the 6th? What's the square root of that? Those are even exponents. What's the square root of that?
A to the second.
A squared, b 3. Okay? Just divide it by 2. That's how we got the square root of x to the 24th. Just divide it by 2, x to the 12th. X to the 10th, divide the exponent by 2, x to the 5th. That's going to be significant. Are we okay there? All right. Last one. And this is the one, ladies and gentlemen, you've had most practice with. The one you're going to see most examples of, the old factorable trinomial. You don't necessarily have to write all this information. Yes, sir.
I have a question.
All right.
If we have another way of doing something on a test, are we allowed to do it like the quadratic formula?
Not only do I count it wrong, I actually count off extra points if you don't do it my way.
Okay, good.
No, I'm kidding. You are free to use any expertise you have, and I'm assuming that there will be a wide variety of methods of doing the same thing. Go for it. Some of you guys are very, very, very comfortable in solving things in a particular way. Others of you, and therefore do not want to learn a new way. That's fine. If you like your method, go for it. I'm showing you, when I'm explaining a method, what I think is the simplest, most straightforward way to get it for those of us who've kind of forgotten how to do it. So, hey, let's note about where these factorable trinomials came from. Hey, they came from multiplying two binomials. Something like x plus 3 times x plus 5. That's a FOIL multiplication, right? X plus 3 times x plus 5.